One really useful part of an interface for a class might be the ability to use operators on a class. So what's an operator? Well, we've talked about a bunch of them, but one example is like the plus operator. The plus operator is really convenient for when you want to indicate that you want one number to be added to another, or one string to be added to another. And it may be useful for you to implement a class that plays nicely with the plus operator. So instead of having to say, my clock dot add and then pass in another clock, you might just have, clock plus clock, and it does the appropriate thing for that particular class. The ability to create operators that apply to your new custom class is called using a overloaded operator, because once again, an overloaded function is just a function that has multiple uses depending on types. Overloaded operators is an operator that does different things depending on the type, and especially depending on a new custom type that you might provide. So when you define a class, you can also define overloaded operators that work on that class. And pretty much all of the operators, most of the operators that we've covered in this class, you can actually overload them to have a particular behavior for your class specially. Now, this is often really useful. For instance, if you want to make a new class that behaves like a numeric type, like for instance, a type that implements imaginary numbers or complex numbers that have real and imaginary components, it might be really nice to be able to add these two complex numbers together just using the plus operator. However, it may not make sense for other classes. If you have a class that represents, a pet, does it make sense to be able to add one pet to another? I don't know. It depends on what you're trying to go for, what the interface for your class should be. If the interface for your class includes the ability to add them together, sure, you might want to overload the plus operator. Now, there are a whole bunch of operators in C++. And very rarely will you be needing to write overloaded operators for most of them. However, some of them do come up occasionally. For instance, the plus operator. That plus operator is really handy for numeric types. It's also handy for strings, and it may be handy for your class. Another operator that's often overloaded is the assignment operator, but we'll talk about that later. Okay, so the important thing to note is that operators are really just syntactic sugar. They're really just a way to call a function in a way that doesn't look like a function. So for instance, right here, we're adding C1 and C2 together. This is really the same thing as saying C1 dot operator plus. The operator plus is special C++ notation to say, I want the operator function with the plus sign. And it's saying I want C1 and C2 to be added together. And this is the case if you implement operator plus as a member function. You see how it's a member function on C1. If the operator plus is just a friend function, you just say operator plus, and it takes two arguments, C1 and C2. There's actually two ways to overload operators depending on which class they fall into. If they fall into the member function class, they are called like that. If they fall into the function class, they can be called like that. So it depends, once again, if operator plus is a member function or just a function. But the important thing to note here is, but when you say C1 plus C2, it's one of these two options. It's either just a function that's called with two arguments, or a member function that's called with one argument, because it already has the other argument is, it's the member of that object. Okay, so given this information, you actually know enough to figure out how to implement these operators, because you know how to add a member function. This is just a member function of a particular name. You know how to write a friend function. This is just a friend function of a particular name. So what did this look like? Well, before we go about how to implement these operator functions, I should let you know how to know if an operator is a member function or just a normal function. So certain operators like assignment, subscript, call, member, these are required to be member functions. Compound assignments are also member functions, like plus equals, divide equals, minus equals, things like that. Really, anything that changes an object's state, those are required to be member functions. That being said, commutative operators that are symmetric, meaning, A plus B should be the same thing as B plus A. These operators generally are functions. Also, the input and output operators, the less than and the greater than, these should also be functions. All right, so let's focus a little bit on those less than and greater than. Why would you want to overload these operators? Well, most of the time because these are really useful when you want to be able to, for instance, see out your object without having to convert it to a string and then see out the string. Wouldn't it be nice if your object could just know how to use these operators directly? So you don't have to say, clock.toString and then pipe that to the output. So the name of the operator for the ability to, write yourself to the output would be operator less than. And the question is, should this be a method or a function? And if you paid attention to the last slide, these IO operations, these are functions. So what would this look like? Well, I want this behavior. I want to be able to say cout less than my clock less than, and just be able to use it when outputting to a stream. Now, if this operator was a method, you would say cout.operator less than, and you'd pass in, your clock. If this was a function, you would say operator less than, and you would take two things, the left-hand side, which is an output stream, and the right-hand side, which is a clock. Which of these two options make the most sense? Well, we can't change the OStream class. So the output stream class like cout, we're not allowed to mess with that class and add a new member function that knows how to handle our clock. So that option is right out, that we can't use a member function. So instead, this has to be a function. And what this function does is it takes two arguments, the OStream and the clock. Now, the important thing to note here is it needs to take the OStream by reference. Why does it need to take the OStream by reference? Because when you're using the less than operator, it needs to change the output stream. A copy of that stream won't work. We need to change the stream itself. Otherwise, how are we going to be putting our clock on that stream? Now, what does this return? Well, if you look back and remember how the various functions that we've written that works as OStreams work, you might already know the answer to this, but let's go through it. So for instance, once again, here is the line that we want to be able to write. We want to be able to output my clock and then, output strings and output endls and output other things. The way this works is it goes by pairs. So the first operator takes cout and my clock. And what it needs to do is it needs to return an OStream so that the later function calls will work. So for instance, if I put parentheses right here, this code does the same thing. It does this process. It returns an OStream so that the next thing can work as well, so that we can take the OStream and then output the string next. So what does this look like? Well, here is our operator less than, and this is just a normal function. It takes two arguments, a reference to an OStream and a constant reference to a clock. Why a constant reference to a clock? Because this operator less than doesn't need to change the clock, and it doesn't need a copy of the clock, so it needs a constant reference to the clock. What does it return? It returns a reference to the OStream so that, later on the other chained operators can work with that reference, can work with that stream. Once again, we pretty much never make copies of streams, but we make a lot of references to streams. Okay, and then the actual body of the function is it's outputting hours and then cours. Now notice this cours here, this is a private data member, which means that this operator is probably a friend function. This is a friend function so that it can access the private data members of the clock. And we have minutes, period, and then once again, importantly, we have to return the output stream so that it can be passed along to anything else. So once again, this isn't a member function. How do you know that it's not a member function? Because this is a binary operator and it takes two arguments. If this was to be a member function, it'd have to be a member function of the OStream, and it's definitely not a member function of the OStream because we're writing it ourselves. The other thing to note here is it returns the stream, and it returns the stream by returning a reference to the stream that it was passed in. And the reason why it's returning a reference to that stream is so that it can be chained down the line, so that various uses of this operator less than can each be changing the exact same stream. No copies needed. We're just doing references of these streams. And then once again, because the operator less than is closely tied to a class, and this class is closely tied to the clock class, this is a good legitimate use of a friend function. We want to make the operator less than a friend function so that it can access the private data members. All right. Another example of an overloaded operator is like doing the operator plus. Now, what is this doing? This is a function, and the operator plus is a function because it's a commutative operator. You know, A plus B should give you the same thing as B plus A. And so what this does is it takes in two constant references to clocks. Why are these constant references? Well, when you add two things together, should that change either of the things you're adding together? No. Do you need to make copies of the things you're adding together? No. So constant references is what you should be doing. And now what does this return? It returns a clock, a new clock, not a reference to a clock, but just a new clock. And hey, look, here's our new clock right here. We're declaring it using the default constructor. And then what we're doing is we're taking our minutes from both of them, adding them together, setting that to minutes, taking our hours together, adding them together, putting that in hours, taking the period from one of the clocks, setting that to be our period. And then we're calling the adjust clock private member function to make sure that, you know, minutes, hours, and periods is adjusted to be the correct values. And then we return our new clock. Now, once again, this is not a member function because it's just taking its two arguments and working with its two arguments. The other thing to note is this is accessing, once again, private data members. And so we need to make sure that this operator plus is a member or is a friend function.